Welcome back to Software Reading. I'm Lord Duman. Today I come back with another Ansys tutorial on how can you do a composite analysis by using Ansys APDL. So as you know the drill, the problem description is explicitly given to you. So as you see from here, the discipline, analysis type, element type, and also the material property of the three components, and even the loading condition are given. So as you see from the problem description, a steel plate of 9 by 200 by 400 mm dimension is coated with 3 mm composite material, carbon epoxy the first one, S glass epoxy the second one, with different fiber orientation arrangements. And also at the middle there is a structural steel. So this arrangement is subjected to a pressure of 100 Pascal. And also it is fixed around 34 edges. So at the end we determine or we extract the total deformation and bone mass stress by using a PDL. So as you see from the property of carbon epoxy, glass epoxy and structural steel is given, and also the loading condition, as you see from the diagram, the center one is steel and the upper is carbon epoxy with 40 degree fiber orientation, and the lower one is carbon epoxy with minus 40 S glass with minus 45 degree fiber orientation. So in this video I'm gonna show you how can you do this step by step. Keep watching. To start with, let us open Ansys APDL. It display like this. So let us start from the preference. Let us select the structure as a discipline, and from the preprocessor let us select our element type, add. Then our element type is shell 181. Then let us proceed to the next step. Let us add the three materials. Let the first material is a carbon epoxy with Young's modulus in the 3 direction. And the shear modulus on the respective planes. And also the density of this carbon epoxy is added here. So the density is this amount. So this is our first material, carbon epoxy, and let us add a new model. This is material 2. So this material 2 has a property of and also the density of this glass is and then let us add the third material. The third material is structural steel. So structural steel is isotropic. So its modulus of elasticity is 2 times 10 the power of 11, and its Poisson ratio is 0.3. Let us add the density. The density of this material is this amount. Once we add the 3 material, let us finish by exit this material model behavior window. Then from sections, shell, layup, add. So the first material has a thickness of 3 and its orientation is 45 degree. Similarly, the second material has a 0 degree orientation, and the third, and also the second material has minus 45 degree fiber orientation. So if you say okay, and if you want to the arrangement of these fibers, potential section range from 1 up to 3. If you say okay, so this is how the fiber orientation is arranged from the one surface to the another surface. So as you see, from the red one is the structural steel, and this gray is glass epoxy, and this is a carbon epoxy. So this is how the fiber orientation is arranged from one surface to the another surface. So from modeling, let us create an area by using a rectangle. So let us create this area. This is our area. So after that we have to mesh this area. So from mesh tool, by using line size control, by using line, so select the 2 horizontal lines, then apply. Let us select into 25 parts, apply. Similarly, let us select the vertical lines, then apply into 50 elements. So if you mesh this, we will get the meshed area. Let us say P call. So this is the meshed area. Having an element of 50 times 25. So from solution, let us define the load, apply structural support, structural displacement on nodes. So as this node, let us fix all degree of freedom at all 4 nodes. So this area is fixed at 4 corner nodes, and after that let us apply pressure on the area, on our area. So select this area as the pressure has a magnitude of 500 Pascal. Let us apply okay. So as this step we can proceed to the solution. So on the pre-processing stage, let us solve the current loading step. So if you solve this, The solution is done. It is good news. So once the solution is done, we can extract any the result you want to see. So from the general post processing, if you want to the plot results like the control plot, nodal solution, if you want the total deformation vector sum, it will be like this. And if you want to see that von Mises stress from here stress, the von Mises stress will be like this. So if you from the elemental solution, if you want to see the von Mises stress from elemental solution, it will be like this. This elemental solution will tell us the von Mises stress at each element. So if you want to see the 3D, let us make it on the total deformation vector sum, displacement vector sum. So if you want to see the 3-dimensional view from plot control, size and shape, let us on the display of element on, then okay. So if you make it, this is an isometric view, we can see this plate. We can see this plate. We can see this plate. So if you want to the result in list form, from list results, from the general post processing list results, if you want to the nodal solution and the displacement vector sum, then okay. So you can get the result in the list format. So this is how can you do composite analysis by using Ansys APDL. So for clarification, this fiber rotation is arranged on this direction. So on the depths of this plate, the fiber rotation is vary from 40 degree to 0 to minus 40. That means the first one, if you assume this is a carbon epoxy, and the center one is the structural steel, and the back surface is a glass epoxy. So this is how can you do a composite analysis by using Ansys APDL. So thanks for watching me.